In this video, I'm going to show you how to conduct a two-factor chi-square analysis with a study that has two variables that are nominal. In other words, these are variables that are categorical in nature. And so in this hypothetical study here, we see, I'm just going to scroll to the bottom, where I have 80 participants, and the participants were evaluated on whether they have cardiovascular disease, labeled as no disease, or if they are diagnosed with cardiovascular disease. The second variable in the study is personality type. So if we define personality type as type A or type B, here you see that those participants that do not have cardiovascular disease, we have 5 of them that are type A. We have a number of them that are type B, and as we continue to scroll down for those participants that do have cardiovascular disease, here you see quite a bit are of the type A personality type and a smaller number of type B. So with a two-way or a two-factor chi-square analysis, what we're trying to do here is to examine if these two variables are independent of each other, or can we develop an ability to statistically predict whether a particular personality type is related to whether a person has cardiovascular disease or not. So to carry out this analysis, I'm going to hit Analyze, and I'm not going to go to non-parametric statistics. For the two-factor chi-square, I want to go to descriptive statistics. Then I'm going to scroll down to crosstabs, and I'm going to click this button right here. That'll take me to a new menu here where I want to identify which variable I want to place as rows and the other variable that I want to place as a column. So I want to put cardiovascular disease along the rows, and you could do the other way, but I'm just choosing to go with cardiovascular disease on the row. And I'm going to click personality, and I'm going to put that on the column here. Now note that I'm going to cancel this, that although the word descriptors are available here, what you'll see when I click this button up here is that those data are coded as zeros and ones, where 0 indicates a person does not have cardiovascular disease, and a 1 indicating a person does have cardiovascular disease, and a 0 is type A and a 1 is type B. And I'll just click this button up here, and you see we have the word descriptions. And under variable view, just to review, under the values is where I indicated the definitions for 0 and 1 for each of those two variables. So to continue back with our analysis of a two-way chi-square, once again I go to descriptives, I go to crosstabs, I'm going to put cardiovascular disease on the row, I'm going to put personality on the column, and then I'm going to click exact, and you see you do have some options, and I'm just going to leave it as asymptotic only. And then when I click statistics, I have to indicate I want the chi-square. Depending upon your statistical approach, you see you do have a number of other options here, but I'm just going to stick with the chi-square. And I hit continue. Under cells, this is where the default of observed. I'm going to click one more box here, and I'm going to click expected. And this is where the null hypothesis approach is applied, where we are going to contrast the observed counts in each cell against the expected counts in each of those cells. And I'm just going to not click any of these other items. I'm going to hit continue. And then at the very bottom here, I want to click display clustered bar chart. So this will present a bar chart of the cell counts for the two variables simultaneously. So now I'm ready to go ahead and conduct the analysis. I hit OK. And as you can see here at the very top, I have my total sample size in case processing of 80. You see that there are no cases that are missing, so all of the cells, all of the participants were identified and categorized on both variables. And the next table is my contingency table, where I have the no disease and disease along the rows, and personality type A, personality type B, and the count is the actual number of observed occurrences for people that do not have disease that are type A and type B. Likewise, for the disease, the count for the number of people classified as type A and the number of people classified as type B, and the expected count, as you can see here, corresponding to type A, B, and the disease and no disease. And although there are a number of statistics that are generated, I'm just going to zero in on the Pearson chi-square statistic. And we see we have a value of 30.561, and that's a pretty large value for a chi-square statistic with a degree of freedom of 1. And you can see that the probability of committing a type 1 error is less than 0.001, less than 0.1%. So what we see here is that we have a statistically significant finding that the two independent variables are not completely independent. There's a degree of dependency, and we can see that here as we scroll down to our bar chart, where the maroon is type B and the light blue is indicated in type A. And so although since the data were nominal in nature, so coded as either zeros or ones, what we do not get with this type of approach is an effect size. So we don't have a magnitude of difference, but we can conclude that there is a dependency on having cardiovascular disease or being diagnosed with cardiovascular disease and personality type, either type A or type B. And we would generate our interpretation based upon our observations that a larger number of individuals of the type B personality type did not have cardiovascular disease, while the opposite pattern was observed for those that do have cardiovascular disease, appearingly that are of the type A personality. And we can state this pattern is statistically significant given the fact that we have less than a 0.1% chance that our conclusions are in error. So this ends our video on the two-way chi-square analysis.